Assalamu alaikum. Here we present our project. Uh, I'm Al Jabbar Habib Abdul Nasser Habib and my colleague Muhammad Saad. The project title simulate the flow characteristic between the stator of turbine blade. What is stator? Stator blades are stationary blades mounted within a turbine or compressor that do not rotate with the rotor. They are positioned in fixed rows and interact with the flowing fluid to control and guide its direction and energy transfer. Function of stator. Stator blades play a vital role in controlling the flow direction of the fluid passing through a turbine or compressor. A stator blade facilitates the extraction of energy from the flowing fluid by carefully designed blade profile. They help convert the kinetic energy of the fluid into mechanical energy. Problem statement. Lack of evaluation flow characteristic between stator blades in gas turbine hinders the evaluate of turbine design and performance. Number two, limited knowledge exists regarding the complex flow phenomena between stator blades in gas turbine, including pressure gradient, boundary layer development, and flow separation. Number three, lack of tools for simulation flow characteristics between stator blade and gas turbine. Objective. Number one, to conduct a numerical study by using ANSYS Fluent to evaluate flow characteristics, including velocity distribution and other characteristics between stator blade and gas turbine. Number two, to validate the simulation result by comparing them with a previous study benchmark cases, ensuring the accuracy and reliability of the simulation. Number three, to use the software specialized into simulation and obtain the best result by using ANSYS Fluent. Computational fluid dynamics (CFD). The science of computational fluid dynamics (CFD) entails applying a numerical algorithm to solve mathematical equations governing these processes in order to predict fluid flow, heat transfer, mass transfer, phase change, chemical reaction, mechanical movement, stress deformation of related salt structure and related phenomena. CFD support physical modeling and other experimental techniques, and many instruction is possible into contract and analyze virtual model for a small portion in the time and money needed for experimental technique. Advantage of CFD. Firstly, cost effective. CFD allows for virtual simulation, reducing the need for custom physical prototype and experiment. It can save both time and resources in the design and optimization process. And number two, insight into complex flow. CFD provides details, insights into complex flow and allowing engineering visualize and analyze flow behavior.
Assalamu alaikum. I'm Muhammad Saad Qasim. I will complete my part of presentation. So let me start with limitation of CFD. Assumption and simplification. CFD simulation really on mathematical model and assumption to represent complex fluid behavior. These simplification may introduce errors and uncertainties that can affect the accuracy of result. Modeling turbulence accurately remains a challenge in CFD simulation. Turbulence models have inherent limitation and assumption, and selecting an appropriate model for a specific flow scenario can be challenging. As you can see here, this is the flowchart. We start and then define the geometry, generate a stator blade 3D, and then set boundary condition inlet and outlet boundaries, and then generate a suitable mesh for the computational domain, and then configure the solver setting, and then the process perform simulation. If no, we go back to the set boundary condition inlet and outlet boundaries. If yes, we go to the summarize the simulation studies data, and then conclusion and address any limitation or difficulties as well, and then the end. Result. Here we insert the stator model in ANSYS Fluent. As you can see here, this is the stator blade, and this is the some details of body. We have body for stator blade and volume in meter cubic and surface area in meter square, and we have face and edge and vertices and so on, solid and shear topology method, automatic and geometry type design modeler. Isolation, the mesh and the model. As you can see here, this is the mesh and the model for the stator blade. The number of iteration used in simulation. As you can see here, this the figure show the iteration. We have the black line for continuity, and the red and green and the blue the velocity in x and y and z, and this one for k, and the pink for omega. Here we have velocity distribution around the stator blade. This figure show the flow direction on the stator blade, and also show the region of flow separation. Conclusion. In this study, we use ANSYS Fluent to carry out a numerical simulation of the stator blade flow characteristic in gas turbine, understanding the velocity distribution and the flow separation process within the stator blade passage was the aim of the study. Through the simulation, the result revealed the complex nature of the flow, highlighting the importance of understanding and controlling flow characteristic between stator blades. Thank you for your attention.